The Babylonian method. This is a method to find square roots quickly. We're going to explain to you how it works and then apply it using APL. If you're interested in the working details, you can look it up on the internet. For the moment, we will just apply the method verbatim. If we want to find the square root of n, we first pick a positive number. Any number will do, but a number smaller than n will yield faster results. We then find n divided by the number chosen. Let's call it R1. This produces a range in which the actual square root of n resides. It's in the range n divided by R1 to R1. It's somewhere in there. We then pick a new number in that range. The one right in the middle, it will do perfectly. We start again the procedure using that new number. We find n divided by that new number. We now have a new smaller range. Again, we pick a number right in the middle of that range, which is shrinking rapidly. Let's call it R3 here. And we repeat until the range is so small that it isn't worth doing it anymore. Let's try with a real example. For example, the square root of 7. Let's pick 3 as starting point. It's as good as any other between 0 and 7. Our first range goes from 7 divided by 3 to 3. Let's choose the one in the middle as new starting point, that is 2 and 2/3. We compute a new range starting at 21 divided by 8, which is the number there. It's 2.625. And we compute a new root by choosing the one in the middle. And we repeat until happy. Right now, R3, when multiplied by itself, gives you a number which is close to 7 to 4 decimal places. If we compute R4, we now have a square root which is close to 7 to 9 decimal places. As you can see, this method converges quickly. This is the Babylonian method. We're going to try to find the square root of 7. Okay, here we go. We're going to try with a number, let's say number 3. Then we're going to find the new range, which is going to be this one here. So it goes from 2.3 to 3. It doesn't matter if it's reversed. Then we pick a number in the middle of the range, and that will be this new number here. And let's do it again. The new range is now going from 2.625 to 2.67, or vice versa. R3 is our new number, and if we look how close we are getting closer to 7. So R3 is a very close value to the square root of 7. I'll try it again. Here's the new range, and as you can see now, the range is getting pretty small. So R4 is now, we've got so many decimals. We're very close. If we look, we have a function here, which basically sets the square root as we start with the half of the number we want the square root of. And we repeat, taking the previous root, finding the range, finding the new root, and we repeat until the previous value is the same as the one we last found. When we do that, there's no point looping anymore, so we stop. And if we try the function, here we go, get this number. Of course, this is a bit silly since APL already has a power function. We already have this, but this is just to show you how you can use APL to use the Babylonian method. That's it.